everybody. Today we're going to look at double angle formulas. We will build on the sum and difference formulas for sine and cosine to find the double angles. Let's start with sine of 2 theta. This is a special case of the sum identity for sine. We can write sine 2 theta as sine of theta plus theta. Bringing back our special formula for sine, we know that sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Putting in the value of theta for both alpha and beta, we get that the sine of 2 theta, which is the sine of theta plus theta, is sine theta cosine theta plus cosine theta sine theta. But because order isn't important, when we look at multiplication, sine theta cosine theta is the same as cosine theta sine theta. That means we can simplify the sine of 2 theta to be 2 sine theta cosine theta. Let's repeat that for cosine. Cosine 2 theta will be cosine of theta plus theta. The formula we need to use is that the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So just like last time, we put in theta for both alpha and beta. We get cosine theta minus sine theta sine theta. This reduces nicely to cosine squared theta minus sine squared theta. But there's something interesting to look at with the cosine of 2 theta. We have different ways that we can write this formula. If we think back to our Pythagorean identity that says cosine squared plus sine squared equals 1, we could solve for cosine squared. That would just be cosine squared theta equals 1 minus sine squared theta. So on our expansion of cosine 2 theta, instead of writing our cosine squared theta, we're going to put in 1 minus sine squared theta. This gives us that the cosine of 2 theta is 1 minus sine squared theta minus sine squared theta. Combining like terms, we have that the cosine of 2 theta could also be written as 1 minus 2 sine squared theta. We could do this one more time. Using our Pythagorean identity, we could solve for sine squared theta, which is 1 minus cosine squared theta. We're going to substitute 1 minus cosine squared theta where it says sine squared theta. When we put in the 1 minus cosine squared theta, though, I want you to put parentheses around this expression. Now we have cosine 2 theta is cosine squared theta minus parentheses 1 minus cosine squared theta. We need the parenthesis to make sure we distribute the initial subtraction sign. If I push through the negative, I'll have cosine squared theta minus 1 plus cosine squared theta. The cosine squareds can be combined. Now I have cosine 2 theta is 2 cosine squared theta minus 1. This shows us there's 3 different ways to write the double angle for cosine. It's really up to you which one you choose, but to make things easier, let's put all of the formulas together on one slide. So we have our double angle for sine, which is 2 sine theta cosine theta. Then we have 3 ways to express the double angle for cosine. You can use cosine squared theta minus sine squared theta, you can use 1 minus 2 sine squared theta, or you can use 2 cosine squared theta minus 1. Let's develop one more formula, using that the tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. Putting in theta for alpha and beta, we'll have that the tangent of 2 theta is tangent of theta plus tangent of theta over 1 minus tangent theta times tangent theta. We can combine like terms. Tangent of theta plus tangent of theta is 2 tangent theta. Then 1 minus tangent theta times tangent theta is 1 minus tangent squared theta. Now that we know all of our formulas, we're ready to try a few problems. To start, suppose A is an acute angle and sine A is 48 over 73, cosine A is 55 over 73. We want to find sine of 2A and the cosine of 2A. To find the sine of 2A, we need to find 2 times the sine of A times the cosine of A. That'll be 2 times the sine of A, which is 48 over 73, times the cosine of A, which is 55 over 73. Putting that in our calculator, we get 5,280 over 5,329. To find the cosine of 2A, we first have to decide which of the 3 versions of the double angle we want to use. For this problem, let's try cosine squared A minus sine squared A. Cosine of A is 55 over 73. We'll square that value. Then sine of A was 48 over 73, which also needs to be squared. 55 over 73 squared is 3,025 over 5,329. 48 over 73 squared gives us 2,304 over 5,329. When we subtract those two fractions, we get 721 over 5,329. In your homework, pay attention to the directions. Some directions may say give the exact value, which is a fraction. Other times it may allow you to give a decimal, and it will specify how many decimal places you need to submit. Our next problem says if sine theta is 5 over 13 and theta is between pi over 2 and pi, we want to find the exact values of sine of 2 theta and cosine of 2 theta. As a quick reference, I have a picture of theta being in the second quadrant. In quadrant 2, sine is positive, but cosine is negative. So when I put in my value of 5 over 13, I put a positive 5 for the opposite, I put a positive 13 for the hypotenuse, and I want to put a negative 12 for the adjacent. 5, 12, 13 is a really common Pythagorean triple that I hope you recognize by now. If you don't, you can always use the Pythagorean theorem to find our missing adjacent side. Now that we have our three sides, we can say that the cosine of theta is negative 12 over 13. For part A, the sine of 2 theta will have 2 times the sine of theta, which was 5 over 13, times the cosine of theta, negative 12 over 13. That simplifies to negative 120 over 169. For part B, we're finding the cosine of 2 theta. This time, I'm going to use the formula 1 minus 2 sine squared theta because I was originally given the sine of theta in the problem. Now I have 1 minus 2 times 5 over 13 squared. This is equal to 1 minus 2 times 5 squared is 25 over 13 squared is 169. Simplifying further, I have 1 minus 50 over 169. If I write 1 as 169 over 169 and then subtract 50 over 169, I get my final answer, 119 over 169. Our next problem says the cosine of theta is negative the square root of 6 over 3. It also says that theta is between pi over 2 and pi, and we want to find the exact value of tangent of 2 theta. Once again, theta is in the second quadrant, where we know cosine is negative, sine is positive. This tells me my adjacent is the negative square root of 6, my hypotenuse is 3, and I don't know the opposite side. I'm going to call it a. Now I have a squared plus negative the square root of 6 squared is equal to 3 squared. This gives me a squared plus 6 is equal to 9. A squared is equal to 3. A is positive because we're in the second quadrant. When I take the square root, I get a is the square root of 3. Our double angle for tangent says that tan 2 theta is 2 tangent of theta over 1 minus tangent squared theta. When you go back to theta, tangent of theta is going to be equal to the square root of 3 over negative the square root of 6. We can write this as negative the square root of 3 over 6, which is negative the square root of 1/2. Plugging that into our formula, we have 2 times negative the square root of 1/2 over 1 minus negative the square root of 1/2 squared. In the numerator, I have negative 2 times the square root of 1/2 over 1 minus 1/2. This is equal to negative 2 times the square root of 1/2 over 1/2. When I divide by a fraction, I multiply by the reciprocal. This is negative 2 times the square root of 1/2 times 2. This is equal to negative 4 times the square root of 1/2. Simplifying that a little bit further, I could try to rationalize the denominator. This means I have negative 4 over the square root of 2. I would multiply by the square root of 2 over the square root of 2, which gives me negative 4 square root of 2 over 2. I cancel the 2 into the 4. That leaves me with 2, so my final answer is negative 2 square root of 2. Our last problem says if tangent of theta is 7 over 4 and theta is in quadrant 1, find the exact value of sine 2 theta. I'm going to start by drawing theta in the first quadrant. It says I don't know the hypotenuse, we can call it h. 4 squared plus 7 squared will give us h squared. 4 squared is 16, 7 squared is 49, h squared is unknown. 16 and 49 is 65. That's equal to h squared. I take the square root of each side. That tells me that h is equal to the square root of 65. Because we're looking for the sine of 2 theta, I know that I need 2 times the sine of theta times the cosine of theta. Sine of theta is going to be 7 over the square root of 65. cosine of theta is going to be 4 over the square root of 65. This gives me 2 times 4 over the square root of 65 times 7 over the square root of 65. 2 times 4 times 7 is 56. The square root of 65 times the square root of 65 is just 65. Again, watch for the directions in the homework. You may have to put in a fraction, like 56 over 65, or it may let you put in the approximation of 0.86.